Okay, so let's continue. So we ended off on 3.2. And 3.2, I've seen they asked this question in your 2021 test. They asked the question in your 2022 test. So you want to know this question. They just changed the variables and maybe they just changed the probabilities, but it's the same question. So it says event A and B are such that probability of B is 20%, or sorry, is 10%, 0.10, and the probability of A union B is 65%. Okay? Given that A and B are independent and non-mutually exclusive, right? Determine the probability of B. Right. So, what are we given? What do we have? We have, let me quickly go here. We have the probability of B, and we have the probability of the union of A and B. Okay, but what they want us to find is the probability of B. Okay? No, sorry. Determine the probability of A. They want us to find. So here I must have typed the wrong thing. Yeah, they want us to find the probability of A. So here of B. Yeah, that is definitely the case, given that A and B are independent. Determine B. Okay, so I typed the wrong thing. I typed here the probability of B, but it's supposed to be the probability of A. Ish. Okay, there, let's go. Right, probability of A. But then also here, then, okay, yeah. So I've consistently made the same mistake. Ooh-wee. I hope you guys are going to need to just double check if, okay, I see they are calculating the probability of A, so that's fine. So ultimately, the formula that you're going to use in order to answer this question is, where is it? I'm looking for it, is this, right? We have the probability of A union B, all right? So we are trying to use that. This is what we have. We're trying to use that to isolate the probability of A. We already have the probability of B, okay? And we know that whenever we have a union, right, we need to minus that intercept. Maybe let me take us to the slide rather than me start to expose my my drawing skills, which are sorely lacking. So can you see here? This intercept needs to be minused, all right, when we have the union, because otherwise it's duplication, isn't? So when finding the union, which is the same thing that was on the slide that they were looking for. So now, because these are they're not mutually exclusive, they say non-mutually exclusive. I think it's easier to say not mutually exclusive. So in other words, they can happen independent of each other. All right, you can have both outcomes happen, or you can have one happen and the other not happen. Okay, so what this is then equals to get your intercept is then, because of that, it is then the probability of A times the probability of B. That's what it is, okay? So, and here I think they say it somewhere, or they share it somewhere. Here you go. This is where you see them breaking that down. So what we then do is we have to use substitution, and this is where we start. So we continue, we know we have to use this formula, right? So then we say, okay, probability of A plus the probability of B, okay, minus this right here. Can you see? Can you see that? What we were just dissecting now. Okay, so then we say, okay, now we substitute the values that we have. We know that A union B is 0.65. They gave that to us. So we put the 0.65 over there. Then we don't know what the probability of A is, but we do know what the probability of B is. It's 0.10. So we substitute 0.10 in, all right, times 0.10 over there as well. Now, like we usually do with any equation, we bring like terms together. So they throw over this positive 10 to the other side. It's obviously going to become a negative 10. Okay. And what else? So what you're then getting is 0.55 is equals to the probability of A. That 0.10 is gone, so minus the probability. Let me actually do it this way. I think it will make sense. Minus the probability of, oh, sorry. Just remove this minus, can say 0.10 times the probability of A. Close brackets. Okay. Right. So now what we then do is we're basically saying this is 10%. Can you see that? 10% of probability of A. So we can also look at this as say this is 100% of the probability, or we can even say it's 1. The number in front here is 1. Can you see that? Okay, so I was just working with decimals. So ultimately, I want to ensure that I don't end up confusing you guys. Ultimately, what we are saying is this is going to be 0. And then we put P, probability of A. Okay, and this is a whole probability of A. Okay, so we can look at this as like terms, and we can say, okay, the whole probability of A minus 10% of the probability of A is going to give you what? It's going to give you 90% or 0.9 probability of A. Is that making sense? This, you can view it as 100% or 100% of the probability of A. Can you see that? It hasn't been decreased or increased by anything. Does it make sense? This is a whole probability of A. But here we're saying 10%. 0.1 is the same as saying 10%, isn't it? So we're saying 10% of A, right? So we're basically saying 100% of whatever variable, because we don't know what the probability of A is, minus 10%. Let me put percentages there. Of whatever the variable is. Okay, but we know that both of these are the same variable. So 100 minus 10 will give you 90% or 0.90, isn't it? We together now? Yes. Exactly the same. It's exactly the same. Okay. One you're working with decimals, the other you're working with percentages, but it's the same. And the other side, nothing has changed. We still have 0.90. 55, isn't it? So then to get the probability of A, what must we do? To get the probability of A, what must we do? Because we want to isolate P brackets A, isn't it? Yeah, we must divide by 0.90 to get rid of this thing. And then obviously we need to do the same thing on the other side, isn't it? So 0.90. Then we see, okay, so the probability of A is equals to, tell me, 0.6. Aha. And then when we convert that to a percentage, it's going to be 61.11111%, isn't it? So this is going to require you going back to your slides and just understanding mutually exclusive, independent. What do the formulas look like when something is independent, when something is dependent, when something is mutually exclusive, when it's not mutually, when something is mutually exclusive, when it's not mutually exclusive, right? So that you know how to then play around with this formula. Because I think this is easy for you guys. I don't think you have a problem doing this, but deriving the formula that you need is where you might have a bit of a slip up, which is this. Because once you have the formula, all you need to do is substitution and then isolate for whichever probability you're looking for. Makes sense? And like I said, you'll see now when we do question 1 from the other past paper, you'll see that it's there. So I'm sure it's also there in the exam for 2023. So we're happy with that. So we now know the probability of A is 61.11%. So then here, question 7, they're asking you guys to do, let me just go straight to it because I'm just want to make sure we cover. They say, determine the linear regression function. In other words, we want to get that linear regression line. All right. So we know that the formula is y is equals to a plus what? bx. That's what we're looking for. Okay. So here they said they want the function. So all that they're asking for is for you to find a and b and then say y is equals to whatever a and b is. Okay. Because they only want the function. Okay. Right. So it goes back to now knowing your formulas. Again, we know that, okay, for me to get this function, I need to solve for A and I need to solve for B. So in other words, you need to look at the formulas for A and B. And if you go, you'll find that your formulas are this one and this one. So then we know, okay, I need to get the totals on my XY, on my X, and also on my Y variable. Am I missing one? It should be an X squared as well. Yes, X squared. I see it here. Okay. So you then, and here they even gave you a hint. They say, do not change the units of either variable from the way they are given in the table above. So we then use this, you're going to be using this. Can you see? And they even said totals here. Okay. So you guys can go through the steps one by one, but at the end of the day, this is what you are going to need to have. These are the totals. Before you can solve for A or B, you're going to need those totals. Once you then have those totals, then we can begin to say, let's solve for B. And we start with solving for B because we know in order to solve for A, we must know what B is. Can you see that here we use B? Is it too small? Can you see there? We use B. So we can't start with A without knowing B. Okay. So there you can see. Again, once you've gotten your totals over here, these totals here, it's just substitution. and ensuring that you do your calculations correctly. Because if you obviously do something, let's say you minus before timesing, for instance, you're obviously not going to get the right answer. All right? It's easy. And how many marks? Let me show you. Oh, no, it doesn't. I didn't show it here. It's 10 marks. Yeah, so you must choose those 10 marks. Easy, easy. You should be looking at it and saying, these are my marks.
How long is the exam?
Is it 2 hours?
Yeah.
Not 3. Or 120. Okay, that makes sense. Because I know 180, yeah, it's 3 hours. So where was I? Here. For yeah, per hour. Okay, so let me not zoom out because obviously then you guys won't be able to see. Let me show you. Let me not split screen. Okay, so we're happy with linear regression. Now, here they just asked you to get the function, okay? So this was the function over here. This is what you should arrive at. This is what you should arrive at. That should be your final answer, okay? However, they could extend this. They could actually then go on to say, so in this question, what were they actually assessing? If we look at the beginning of the question, we see the following table indicates the years of experience of a sample of salespeople. We are the people Pty Ltd. So that's the name of the company. And the income earned last month by each salesperson in the sample. Okay, so the income earned each month, or sorry, last month by each of the salespeople. Okay, so then it goes on to say by completing, so they don't actually state the linear relationship you're trying to establish. But here, what you're trying to establish is there a relationship between the income earned last month and the years of experience? Already, just looking at this data, you can kind of see the longer you've been here or the more experience that you have, the higher your salary. Nope. Here's 11 and here's 31. Okay, there's a stark difference. Here's 12 and here's 39. Okay, so no. Okay, but one would assume that the longer you've been, the more money you should make. But clearly here you can see it's not exactly the case. You see. So that's what you're assessing. So here, what are they then looking at? You can see Y. Well, what is X first? Let's see what X is. X should be the number of years, okay, of experience. Okay, so Y is the income earned last month. So then we're saying X, in other words, which is the dependent variable, saying, oh, sorry, Y is the dependent and X is the independent variable. So we're saying for every year of experience, right, you should have 0.61 added to your salary. Remember, A is the intercept, right? So this is the amount you're definitely going to have, regardless of the number of years of experience. Okay, and remember, this is being calculated in thousands. Okay, so bare minimum, you're going to have 27,260. Okay, the income earned increases on average by 0.1000, starting from a base income of, okay, remember I told you this is fixed, so that's your base. Okay, the equation indicates Okay, so if you were to interpret it. So sometimes they can say predict based on the years of experience. That's all that I was trying to get to. But here they just wanted you to get the function. Okay, right. Anyway, sorry. I hope I didn't end up on a huge wind. But yeah. So that is your exam for 2022. Now going to 2021, your suggested solution. Here, there was only one question that we could get out of your past quant. And here, they were looking at probability, which I know for sure they're probably going to ask you guys in the exam, sorry, in the assessment. Yeah, your test too. There will definitely be probability. So here, what are they looking at? A contingency table. Gives the results of a sample survey of South African male and female respondents. They like this thing. With regard to the mode of transport. Hopefully that's not too personal. Is it fine? Right. So the first question they ask, there we have our, what do we call it? Contingency table. And they're saying, what is the probability of a randomly selected female respondent given that they travel by bus? So can you see, this is a conditional probability because we want a female respondent, right? But we also want it to be given that they travel by bus. So there's two conditions that, well, there's a condition that must be met. We don't just want a female. We also want that that female should travel by bus. So remember, conditional probability, the formula is what is the probability of A given that B is met? Okay, that's how we interpret this here. Okay, so you simply say to yourself, okay, what is the total number of female respondents that travel by bus? It's 85, isn't it? Okay, because we know that these females obviously travel by bus, so they've met the condition. Does that make sense? But then we know that we need to divide by, that's a good question, the total probability, or let me say the total of buses. Okay. So then that, here you can see, it's 85 divided by your 175. Okay. All you need to remember is we're not dividing by the total number of respondents, okay, when it comes to conditional probability. Okay. So there, your answer, your final answer will be 48.57%. Okay. So that's the first thing they asked. Usually they don't come out the gate with such a hard question. Well, a more challenging, let me say, question. So here on the second one, they're saying, what is the probability of randomly selecting a respondent who is male or travels by taxi? What do we know whenever we see the word or before you see the answers? What do we know whenever we see the word or? What is the probability that Aubrey will come to class or that he will be just on campus? Can you see when we use the word or, we're happy with any of the outcomes? Not necessarily. But again, I can see why you're saying that. But at the end of the day, we're basically saying we want the collective probability of both those outcomes. Because we're saying, if it comes to campus, we're happy with that. If it comes to class, we're happy with that as well. Does that make sense? So in such a situation, we would then add the probability of each of those two potential outcomes. Does that make sense? So whenever you see or, you must already be like, oh, okay, it's addition of the two potential outcomes. Make sense? Does it make sense? Okay. You would have minused. Ooh-wee. Okay, so probability of getting a male respondent. We have to go back to our table. Where are our males? Males are over here. Okay, so total males is 210. So 210 divided by total number of respondents, we get 210 divided by 400. Then, or travels by taxi, males or travels by taxi. So taxi, we have 100 people in total. Okay, 100 divided by 400. So then here you can see we're adding 210 divided by 400 plus 100 divided by 400. And here now, oh, I forgot to mention this. We need to subtract, because it's basically the saying the probability of getting males union probability of getting respondents who travel by taxi. So remember, whenever we have union, there's a overlap. And we have to minus that overlap, or that, yeah, the overlap in the intercept. Okay, so this is why they're then saying minus and the probability of male and their taxi respondent. Is it making sense? Yes. Male who travels by taxi. That's not the data that they've given us. It's something that it's just randomly selected. It's not part of it. It is part of the data, because remember we did a survey on people, asking them about how they've traveled. They can't ask you probability without giving you data, because then what are you basing your probability on? So why are we minusing? Love it. I love it. I love it. I love it. Ashen, I'm hoping that you're not struggling with this question because your lecture can't draw. So remember, we have potential outcomes. Ne? Whenever we discuss in probability, we're discussing potential outcomes. So firstly, let me go back and let me zoom in here. Firstly, we have the probability of selecting males. Selecting male respondents, isn't it? This is what we call the universe. Now, all potential outcomes. We might not even select a male. We might not even select somebody who travels by bus. By taxi. That's part of our universe here, isn't it? Of potential outcomes. Now, you guys tell me, is it possible? The other outcome we have is of selecting a respondent who travels by taxi. That's what we're interested in. All right. There are other outcomes, but we're only interested in those two. But now, before I draw that, tell me something. Is it possible that we might just select a respondent who travels by taxi, who also happens to be male? Is it possible? It's possible. So that means that we can actually select a respondent who falls under both probability that the respondent travels by taxi. And if they are both, that means that they would fall in both, isn't it? Can you see that? That's the intercept. So if we are saying we're happy with this probability, we're happy with it, and we're happy with this potential probability, we want the total of either of these probabilities happening. Can you see that there's now the potential for duplication? Because let's say here we're saying, I see your hand, I'll be with you now. if we go back to our graph, we're saying the total number of males is 210, isn't it? So let me do this. There's 210 people that we might select who are male. And from the taxi respondents, we have 100 that we might select, isn't it? Let's go back. 100. But that's both male and female. So can you see if we just say 210 over 400, okay, because this gives us then the probability, isn't it? Plus your 100 over 400, probability for taxi. If we just add them, we might include, in fact, we will include those that belong to both. In other words, they're both male and female. Duplicate, sorry, male and travel by taxi. Can you see that? Select 60 where? Yes, where did we get the 60 from? And yes, because they remember we're saying what is the probability here when we minus, we're saying the formula isn't its probability of male respondents, isn't? That's this here. Then here we're saying probability of taxi respondent, isn't? Then we're saying minus, because we don't want to duplicate, the probability of the respondent being male and a taxi respondent. And that's where the 60 is coming from. I hope my drawing was sufficient. Wow, you can't make people happy, Shane. It's okay. It's fine. You'll still get a burger if you give me 90. I'm not negotiating. I'm not negotiating. So your probability is obviously then gonna be 62.5%. Eventually, that is what you're going to come down to once you put in percentage. So let's go to number 3. Okay. Number 3, what is the probability of randomly selecting a respondent who is not male? Not male. So again, there are so many in this universe. There are so many outcomes because we can select so many outcomes that we can select. But we're just concerned with ensuring that we do not select a male. That's what they're asking here. What is the probability of randomly selecting a person who's not a male? So the easiest way, because you have one of two ways. You need to find out all the other potential outcomes where someone is not a male, or you can just say, what's the probability of getting a male minus 1? Because we know all our probabilities add up to 1. Okay, so we've obviously chosen to go that route. So we say, what is the probability of getting a male? We know that males total is 210. Okay, and we know that our total respondents is 400. Cool. So no sweat. 210. Where am I? Ish. Yeah, ne? We're here. All right. 210 divided by 400.
Not male.
Yes, not male. Why are we taking that? Because remember we are looking at what is the probability of not male. In other words, we want outcomes other than a respondent who is male. We want all the other outcomes. Why don't we take the 190? Yes, we can do that.
Just take the 190.
Let's see. we actually can. And here you see that's actually how but basically that's females, huh? Yeah, because that would cover all of the not male. But do you know why it's easy in this question to do that? It's easy to do it because we only have two, in terms of we only have females and we have males. Remember the example we had? Let me actually show it to you. This is just for the benefit of those who are gonna watch this via YouTube. So here, can you see? We have mining, we have financial, we have services, we have retail. So if we say what is the probability of not getting retail, we have to then add up all three of these, which is harder than just saying minus 33 over 170. Can you see that? So yeah, we can do it that way. It would also work. But yeah, traditionally, usually, it would be easier to say 1 minus not whatever you are assessing. But yeah, I'm glad I can see you guys are applying your minds to this. So there's your probability, and then you should have 47, no, yes, 47.5%. Then now, here you can see, this is what I was telling you. They like this question. We're just going to read it, but because I now know you guys know how to do this one. And I think I actually made it easier here because there in the initial one, I think I included too many steps and things like that. I think I might have even complicated it or made it seem more complex than it needed to be. So here, you've got the events A and you've got events B. Such that probability of A is 20% and the probability of A union B is 0.55 or 55%, right? Given that A and B are independent and non-mutually exclusive, determine the probability of B. Give your final answer as a percentage to 2 decimal place. So again, you go back to your formula. So you go back to your formula to say what is the union of A and B, and we know it's the probability of A plus the probability of B minus the intercept. All right, and then we know since they are independent, they don't influence each other, the probability of A intercept B, all right, or the interception between the two is then probability of A times the probability of B. In other words, the probability of A and, you know, when we say and, we are saying times, isn't it? Okay. And so we then now know this to be 0.20 times the probability of B because we don't know what B is. So we then substitute that again into our main formula, which we have done here. And then we again put like terms together because we are doing this step by step to isolate B. So here again, we see 0.20. Can you see just the amounts have changed? 0.20p, 0.20 probability B minus your probability B. You then obviously get 0.80 probability B is equals to 0.35. And then obviously we divide to isolate your probability of B, and voila, we get 0.4375, which then tells us that we have a probability of 43.75%. Yeah, so I think when going through practicing this question, use this 2021 question just to make your life easy. Then we end off on a very nice light note. It's not light. Yeah, if you actually don't know these things, shame. You'll be looking at 10 marks out of 60, yeah? That you don't have. So 1.3, question 1.3, here they're saying, discuss briefly each of the 5 basic properties that apply to every probability. Okay? Probabilities are non-negative. They can't be negative values. Remember, we're saying, what is the potential chance that this may happen? Okay. Then normality. What are we saying with normality? We're saying the sum of the sample space, all the probabilities equals to 1. Okay. Then additive. If A and B are mutually exclusive, right? In other words, the probability of A union B is equals to the probability of A and the probability of A plus the probability of B, if they are mutually exclusive. If they are non-mutually exclusive or not mutually exclusive, then that means we need to subtract. So then now we've got the complementary probabilities. And that's where we were saying, what is the probability of not getting a male respondent? And there you can see, you just say, okay, we know that the total probabilities or total outcomes is equal to 1 minus the probability we don't want, to get all the other probabilities collectively that we want. So, right. And then obviously sub-additive. How do you pronounce this, guys? Assist. Sub-additivity. For any two events, A and B, okay, probability A union B is less than or equals to the probability A plus probability of B. Let's just see how they worded this also in our slides, because I know they looked at the principles here as well. Probability, chance to the event, types of probability. Maybe I might not find it. Properties of probability. This is what you're looking for. Yes. 1. Probability value lies between 0 and 1. If an event can't occur, it's equal to 0. If an event is certain, it's equals to 1. Sum of probabilities of all possible events is equal to 1. Okay. So run with these, actually. Complementary probability, we spoke to that. So run with these 5, not what I gave you guys. I think I'll also amend the suggested solutions since they are blurry, and I'll make sure to put these ones before sharing it again. Coolio. Are we done for the day?
No. Thank you.